Hi dear students, next we are going to the important second topic, means the second important topic of this chapter, the fundamental theorem of arithmetic. In the introduction of the chapter, I told you we have to study about two things in this chapter. What was the two things? One was Euclid's division algorithm. That's what we have studied in our previous class. And in this class, we are going to study about the fundamental theorem of arithmetic. Now, let me explain what is the fundamental theorem of arithmetic. You are very familiar with this one actually, but you may not have heard this word. That's the fact actually. Okay, I will explain what it is. You know what are composite numbers, right? What is composite numbers? A composite number is a number which is having more than one factor. So, the fundamental theorem of arithmetic states that any composite number can be expressed, or in other ways we can say that can be factorized as the product of primes. That means if you are taking any composite number, you can write it as the product of prime numbers. You can express it as the product of prime numbers. That means if there is any composite number, definitely you can write it as the product of prime numbers. Not only this much more deeper. In other ways we can say the deepest point is this, that when we are expressing any composite number as the product of primes, we can express it as a unique way, means there is one and only one way to express them. If we are not considering the order, that means for example 6 is a composite number, right? 6 is a composite number because 6 belongs to the table of 2, it belongs to the table of 3, it belongs to the table of 6. That means the factors of 6 are 2, 3 and 6 including 1. So we can say that 6 is a composite number definitely. So this 6, how can you express 6 as a product of primes? 6 can be written as 6 is equal to 2 into 3. 2 multiplied by 3. That's 6, right? Now, if you are writing 2 into 3 or if you are just changing the order 3 into 2, it doesn't matter, both of them are same. That's what it means, that you can write it in the unique way. If you are not considering the order, means if one fellow is writing it as 2 into 3, another guy is writing it as 3 into 2, it doesn't matter. If you are shuffling the order, it doesn't matter. But all the prime numbers will be exactly the same itself. Whoever does it, it will be exactly the same. That means there is a unique way of representing this one. Actually, this is the main important, what we can say, the core part. This is the core part which we are going to use in this lesson. Not only in maths, in plenty of other fields also, this fundamental theorem is being used. That's why actually it is named as the fundamental theorem of arithmetic, because the character of integers, the properties of integers, all these things, it comes inside this theorem itself. From this theorem, we are concluding the property of integers. That is the importance of the fundamental theorem. That's why actually it is named as the fundamental theorem of arithmetic. Means if you are doing arithmetics, really this theorem plays a very important role. It plays a very vital role in this one. So here in this chapter also we are going to use the same theorem for multiplication. Actually, to find the HCF and LCM of some numbers by using the prime factorization method. We have studied already these things in our previous classes. I mean in our 8th class and 9th class, we have studied about this fundamental theorem. And one more thing we have to study in this chapter is one main thing, formula. That means suppose A and B are any two integers, any two positive integers, and if A and B are any two positive integers, the LCM and HCF of these two numbers, the product of the HCF and LCM of these two numbers will be exactly equal to the product of the numbers. That means LCM of A and B into HCF of A and B should be equal to A into B. If you are taking any two numbers, if you are multiplying them, you will get a product. That should be exactly equal to the product of their LCMs and HCF. That is the important theorem, or that is the important statement which we are going to study in this chapter and going to apply in the further upcoming questions also. Okay, let us get into the question number 1. So here you have to express the given following numbers as prime factors. Means that is the initial part, that's the starting point, how to express something as prime factor. If you know this one, from this one only you will have to bring out the HCF and LCM. Means this is the important point, or this is the important or the basic, that's the word. This is the basic thing which you have to study in this chapter, in this particular topic. In this topic you have to study this term itself. So that's why I said that it's so important. Okay, so now let us get into that one, get into the first question. What is the first question? 140. Let us divide it. 140. When dividing it, how much did you got? 140. See, while dividing also you must know some particular methods to do this one. That means when you are dividing 140, see, this 140 actually it belongs to the table of 2, right? It belongs to the table of 5, 7, 14, 10, right? There are plenty of factors, you know. Which one should you choose? That's the important point which I want to share with you today. Which one should you take? You have to take the least prime number. You have to take the least divisible prime number. Here, as 140 already it is an even number, without any doubt we can take 2 itself. So starting with 2, let us divide 140 by 2. How much times? 70 times. Again 70, it's an even number. Again we can divide it by 2. How much times? 35 times, right? We are just, whenever we are dividing by 2, just write the half of that one, that's enough. There is no need to divide and check it off. Just write the half, that's enough. So 140, half, 70, and again 70 dividing by 2, 35, half of 70, right? Again 35, that's the number which can be divisible by 5. 5 will be the least prime which can be divisible. Now dividing it by 5, how much did you got? 7. Forget out, stop right there as you got the prime number. Whenever you are getting the prime number, stop it there. And now let us express all these things which is lying outside of this column. Let us take all these things and let us express 140 as the product of these numbers. Come on, 140 is equal to, how will you write? 140 is equal to, here you can see 2 into 2, 2 times it came. So we will write 2 square. Every second you have to remember this thing. These points are so important, okay? That means 2 into 2, rather than writing 2 into 2, we will write 2 square, because every time you have to express the given numbers as the powers. You have to represent them in powers. Clear? So we will never write 2 into 2. That's what we used to write when we were studying in our 9th class. But now we are grown up, we came to the next section, so a little bit higher level, okay? So that's why 2 square, we will write 2 square. So 2 square into 5 into 7. So 140 will be expressed as 140 is equal to 2 square into 5 into 7. Clear? Next number, 156. Obviously, it's also divisible by 2. Let us divide it by 2. How much times? By dividing it by 2, 78. Right? 78. Again, it's an even number. Divide it again by 2. How much? 39. You got it as 39. Now you got 39. 39, anyhow, it's not an even number. While checking, you can understand, yeah, it's divisible by 3. Exactly. Now, by 3. Dividing it by 3, you got 13. Now, 13 is a prime number, so stop it there. Stop right there itself. Okay, dear students, let's go to the next question. What's the next question? We have to show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5 for some integer q. That means if you're taking an integer q, you are going to prove that if you're taking any odd integer, any positive odd integer, it should be of the form 6 cube plus 1, 6 cube plus 3, or it should be of the form 6 cube plus 5. See, this is a very important question, because plenty of times the same question, means the same category, was repeated. We have seen that it was repeated in plenty of the board examinations. So that much it is important. Okay. So in some questions it may be 2q plus 1, it may be 4q plus 1. Right now I am going to tell you how to understand to do that one. If you understood the technique behind this one, if you understood the algorithm, or if you can understood the steps If you can understand the steps which are involved in the whatever question you are getting, you can do it very simply. Okay, so today I am going to tell you every step, so don't skip the video, just watch it fully. Okay, so now let's start with the question. See here you have to prove that it is of the form 6 cube plus 1, right? 6 cube plus 3, 6 cube plus 5. What's the number there? It is 6. So whenever you are seeing that number, this will be the first step. Let us assume, let us check it, let us assume like this. The first step will be starting like this for everything. For every typical type, means if you are taking this typical type of questions, every time this will be your first step. Let n be the given positive odd integer. I use the word odd integer specifically because in the question it is mentioned odd integer. That means if it is mentioned even integer, you will have to select let n be an even integer. Clear with that? So here, as it is given that it is an odd integer, you have to prove that it is an odd integer. That's why you are choosing that same term. So that's why we are writing like this. Let n be a given odd integer, positive odd integer. Okay. Next step is so important. Listen to this very carefully. On dividing n by 6. On dividing n by 6. Why we are dividing it by 6? It's because you are supposed to prove that 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. What if you have to prove 4 cube plus 1, something like that? You will have to divide it by 4 itself. What about 2? If it is 2 cube plus 1, exactly you will have to divide it by 2 itself. Hope you understood that, right? So this is the way how to understand a question. Okay, so that's why in the next step we will write like this. On dividing n by 6, let q be the quotient and r be the remainder. Anyhow, if you are dividing a number by another number, there will be a quotient and definitely you will get a remainder also. Okay, so here we are taking that let n be that number, so that we are dividing by 6 and we are receiving q as its quotient and r as its remainder. Now you got. So this is familiar with a statement. Which is that one? What is that statement? It is Euclid's division lemma. So let's apply that one here. So next step, by applying Euclid's division lemma. In this one, if you are applying Euclid's division lemma, what will you get? N is equal to 6q plus r, comma 0 less than or equal to r less than 6. Why 6? Because here we are dividing by 6. Clear? That's why here we are dividing by 6. That's why we are going to take it as 6 itself. Now we got the equation, Euclid's division lemma. With that lemma we got an equation. What was that equation? N is equal to 6q plus r, where 0 less than or equal to r less than 6. What does it mean really? 0 less than or equal to r less than 6. What does that thing means? That means the value of r, it can be 0, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. Is it? No, it cannot be 6, right? Because we have written less than 6, means it should not be 6. That means all the possible values of r are, what are they? From 0 to 5. From 0 to 5 they can take any values. So these are the possible values. So the next step we will write, therefore the possible values of r are 0, 1, 2, 3, 4 and 5. Now you got the values of r. In this equation, in this above equation, what you are going to do in the next step? You are going to substitute the value of this r one by one. So first of all, let us give the value, let us substitute the value of 0. What happens to the equation if you are giving, what is the equation? N is equal to 6q plus r. Inside this equation, if you are giving the value 0 for r, what will happen? The equation will become n is equal to 6q. You are right, 6q, right? That's over, nothing more. Then what about next value? When r is equal to 1, now let us give the value of 1. When r is equal to 1, what will happen to that equation? N is equal to 6q plus, tell me, 1, right? 1, because we are substituting the value of r is equal to 1 into this equation. That's it, nothing more. We can't do anything, right? Now next step, another one. Let us substitute the next value. What's the next value? R is equal to 2. So next step, when r is equal to 2, when r is equal to 2, what happens? N is equal to 6q plus 2. Similarly, next one, when r is equal to 3, n is equal to 6q plus 3. When r is equal to 4, n is equal to 6q plus 4. When r is equal to 5, finally, n is equal to 6q plus 5. That means you substituted all the values of r and you received each n. So what are the values of n which you got right now? Therefore, n is equal to, what are the values? 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. This much values you got it. Okay, among this one, let me ask you one question. What about 6q? Is it odd or is it even? Exactly, it is even. How can you conclude that it is even? Because any number multiplied by an even number will be even number itself, right? Any number multiplied by an even number will be even number. Similarly, any number, if an even number is given and if you are adding another even number to that even number, the sum will be, or the resultant sum will be another even number. That's what we have studied in our previous classes. I mean in our 9th class, 8th class, right? We know about that one. Euclid's theorems we have studied it in our 9th class. So same thing we are going to apply here itself. Check out 6q. Now what about 6q? 6q will be definitely an even number. Why? Because 6 is already an even. So q, what is q? Q is the quotient. Quotient can be an integer, right? Here we have assumed that it is a positive integer. In the initial part we have assumed like that. So definitely q is going to become a positive integer. So even if it is it may be even or odd, it doesn't matter. If it is multiplied by 6, definitely the result will become even itself. That means 6q is even. Hope you got it. What about the term 6q plus 2? There is also a term like that, right? N is equal to 6q plus 2. You already know that 6q is even. Right now we stated it. So 6q plus 2, what about that number? Adding an even number, 2 is an even number, right? Adding an even number to an even number. The resultant will be another even number. So definitely we can state that 6q plus 2 is also even. What about 6q plus 4? That will be also another even number, right? It will be also another even number. How can we conclude that one? Because you're adding 4 to that one, so definitely it's also going to give an even result itself. So 6q is an even number, 6q plus 2 is an even number, and 6q plus 4 is also an even number. If these three are even numbers, what about the other numbers? What does it mean? It means that when n is odd, whenever n is odd, if you're getting n, the value of n, if it is odd, it should be of the form 6q plus 1, 6q plus 3 or 6q plus 5, because the leftover 3 of them, other than this, the next 3 of them, they are definitely even. We proved it right now. We stated it very clearly. So leaving those 3 behind, we can say if n is odd, if the value of n is coming as odd, definitely it should be of the form 6q plus 1, 6q plus 3 or 6q plus 5. So finally we will write thus. When n is odd, it is of the form 6q plus 1, 6q plus 3 and 6q plus 5. This is how you have to prove. And in the same question, if they are asking about even, number, here it was odd number, right? If they are asking about even number, towards the last step, your steps will be exactly the same. But in the last step, we will say, see, 6q is already an even, we know that one. So 6q plus 1, what about next number? Next number, and if you are taking an even number, the very next number will be an odd number itself, right? So definitely like that we have to conclude, even though if you are repeating the same steps, but towards the conclusion, you have to define about what you have received. Means you have to match it with the question which is asked to you. So like that you have to twist it, okay? It's not that you have to by heart this question and go and just go to the examination hall and just copy it down, whatever you have studied. It's not possible like that. You have to understand this one. Like that you have to use it. Then only you will understand every questions. With respect to the question, you have to give the solution, okay? Hope you understood.